Alright, so this is an especially nasty problem. So congratulations to those of you who figured it out already. For those that didn't and this is driving you crazy, let's just go through this. What we have here is a situation where x decomposes more quickly than y. So that means even though we start with more x, eventually the amount of x is going to be less than the amount of y. So even though we start with more x, eventually the amount of x that's left is going to be less than that of y, simply because it decomposes more quickly. The difficulty here is figuring out when that happens. We're told that this is first order kinetics. So that means the natural log of the amount of x that remains at any given time to x0 is going to be minus kt. If we raise each side to the power e, we get, now if we exponentiate each side, take each side and raise it to the power e, we would have x to x0 is going to be equal to e to the minus kt. Okay, and we can therefore find the amount of x left at any time later as equal to x sub 0, the initial amount of x, multiplied by e raised to the minus kt. By the same manner, we can express how much is left of y as being the initial amount of y0, times e to the minus kt. Okay, there are two different k's, k for x and k for y. So let's make sure we differentiate those. Okay, so we have expressions that relate the amount of x and y that are left at any given time later. The ratio of x to y is going to be greater than 1 at the start. They just tell us we're starting with more x than we have y, but x decomposes more quickly, so this ratio begins to decrease. At some point after the reaction starts, the ratio x to y is going to be equal to 1 when they are equal. After this point, x to y is going to be less than 1 because x is decreasing more quickly than y. So we're going to solve for the time in which x to y is equal to 1. At any point after that, x is going to be less than y. In other words, we're looking for the time for which the ratio x to y, the current amount of x to the current amount of y, is equal to 1. So we're looking to solve for the time at which the amount of x to the amount of y is equal to 1. After that, x is going to be less than y. Okay, we're going to simplify this expression a little by our understanding of math. So we're going to pull out x0 and y0, and they're going to be multiplied by e to the minus kx minus ky times t. Okay, and a reminder, this is equal to 1. At this point, we're going to take the natural log of each side. Because remember, what we're trying to do is we're trying to solve for this t, so we need to get the t out of this exponential expression. The natural log of 1 is going to be equal to 0. Now we'll focus on this left-hand side. Okay, so here we have the ln of x0 to y0 is equal to minus the difference between the rate constants times t. And finally, we can solve for t. So we have a single expression for t. We are given the values of y0, x0, and y0, and we have the means to determine both kx and ky from the half-lives. All right, so I've calculated kx and ky from the half-lives. We see that the half-life of x is 75 minutes and y is 1.5 hours, so we can calculate the k. So we now have values for kx and ky. We need to find initial values for x0 and y0. Going back up to the statement of the question, we see x starts with an amount that's 75% greater than y. That tells us that x0 is equal to y0 times 1.75. Continuing on that, we see the ratio of x0 to y0 is going to be equal to y0 times 1.75 divided by y0, or simply 1.75. So we can take this value and substitute it in over here. For the denominator, we can plug in the values of kx and ky that we've calculated. And finally, we can churn out a calculator answer. And I get 363.39 minutes, which we convert to hours as 6.056 hours, or a final answer of 6.1 hours. Let's review what we've done here. Okay, we started out with two gases, x and y, and we had more gas x than we had gas y. But because x decomposes more quickly, eventually we would reach a point where there was less x than y. So we set up a ratio of x to y to determine when that time was. Beyond 6.1 hours, there will be less x than there is y.